Let's deal with a question that appears in exam but usually gives even professionals problems. So, you're given 2 sine squared x minus 5 sine x cos x plus 3 cos squared x is equals to 0. So I'm going to show you two methods to solve this stuff. The first method is going to be very easy and simple to memorize. The second method is not as easy as the first method, but it is important because it appears in trig identities. So there is a case where you have got no choice but to use it. So both methods will be important, but whenever you see this question, immediately use the first method. But the second method is important because it appears in trig identities. So whenever you're caught in a corner, you just use the second method. So let's talk about the first method. So whenever you see sine squared and you see sine cos and then cos squared, notice that we actually have three terms, right? This is 1, 2, 3. And there is no common factor, so we can't factorize, right? We can't take out a common factor rather. So whenever you see sine squared and then you see sine cos and then cos squared, all you have to do is to divide everything by cos squared, right? So why are we going to divide by cos squared? So we're dividing by cos squared because we want to end up having tan. So I'll show you the significance of this. So we're going to divide everything by cos squared. So it's just the method. So all you have to do is just to divide everything by cos squared. So notice sin squared x over cos squared x is tan squared x. So eventually you have got 2 tan squared x. Right? That was the goal. That was the goal. That's why we divided everything by cos. Now notice that this one will cancel with one of them. So you are still left with sin over cos, which is tan. So then this becomes 5 tan x. And then here, notice that cos squared over cos squared, right? This just cancels out. So you are eventually left with this 3. Now notice that we're back to the situation that most people are good in trig now, right? So this is quadratic in trig. So you factorize it as normal, you factorize it just like quadratic equations, right? So when you factorize this, if you want to know the actual way to factorize, or if you want to know how to pretend as though you're factorized, I have put the link on the top right of the screen. So our factors will end up having 2 tan x minus 3. So we'll end up having 2 tan x minus 3, and then we'll also end up having tan x minus 1. So we'll have tan x minus 1. So this will be our factors. So now when we solve for this, we're going to end up having 2 tan x is equals to 3. And when we divide both sides by 2, you'll end up having tan x is equals to 3 over 2. So we have tan x is equals to 3 over 2, or tan x is equals to 1. So now we can get our reference angle. So let's get our reference angle. If you don't know how to factorize when there is a 2 in front, you can pretend as though you're factorized. How can we pretend? When you use the quadratic formula, you'll actually get these two as your answers. So whenever you get your answer as, because your first answer will be equals to 1, right? So what you'll do is that you'll simply say, okay, fine, this is not erasing, I don't know why. So eventually you'll say tan x is equals to 1, right? So when you get your answer as 1, you say tan x is equals to 1. Then you just take this to the other side of the equation. When you take it to the other side of the equation, you'll have tan x minus 1 is equals to 0. Then that's what you put in the first bracket. So for the other one, notice that in your calculator, you'll actually have 3 over 2 as one of your answers if you use the quadratic formula. So what you'll do on the side is that you will write tan x is equals to 3 over 2. And then what do you do when you've got a fraction? Whenever you've got a fraction, you can make this over 1. And then you can simply cross multiply. So 2 times tan x is 2 tan x. And then 1 times 3 is 3. So we're kind of like reversing the process, right? So notice that when we take this to the other side, you're going to have 2 tan x minus 3 is equals to 0. So then that's what you put in the other bracket. So you have pretended as though you have factorized. So let's continue. So that is just if you don't know how to factorize. Okay, if you want the full video, I put it on the top right of the screen. So this is what you'll have, right? So let's find out our reference angle. Your reference angle is 56.31. So that's the first one. And then what gives us 1? Well, it's obviously tan 45. So we don't need a calculator for that. But if you don't know that by head, well, if you use arc tan 1, that will give you 45. So reference angle is 45. Alright, let's talk about the general solutions. So The nice thing about tan is that with tan, you're only going to use one of them. You're only going to use the one that says plus k 180 and k is an element of integers. So you're only going to use this one. You're not going to use the one that says 180 plus, even though it's correct. The reason why is because since the period is short, they both give us the same answers. So mentioning the other one is like repeating the same answers. So there is no need for the other one. So the nice thing about tan is that whenever it comes to tan, you're only going to use this one, right? So whenever it comes to tan, just write one equation. So our reference angle is 56,31. So we're just going to say 56.31 plus k 180, and then k is an element of integers. So we're done with the first one. We don't need to mention 180 plus. So now let's talk about the 45. So we're just going to say our reference angle, which is 45 plus k 180, and then k is an element of integers. And this is it. You're literally done. All right, let me show you the other method, which is important because it appears in identities.
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
Watch the video that is found at the end of this video for the prices and the updated contact details. Talk about this, the other method rather. So the other method, notice that we have got sine squared, and then we've got sine cos, and then we've got cos squared. This is exactly the same as having x squared and then xy and then y squared. So the other method, because this is actually important, it appears in identity, right? So here you could divide by cos squared because it's general solutions. However, in identities we can't. So whenever you see sine squared and then sine cos and then cos squared, you have to treat it as this type of factorization. Notice that this is actually the same as 2x squared, and then we've got minus 5xy, and then we've got plus 3y squared, right? So this is factorizable. So how do you factorize this type of situations? A lot of people don't know how to factorize this. So if you don't know how to factorize this, the next thing is that we can also pretend as though we factorized it. How do we pretend? So let's pretend like we're factorized. So in order to do that, what you have to do is to ignore the y. So pretend as though y is not there. Pretend that it is just 2x squared minus 5x plus 3, right? So pretend that it is this situation. So pretend as though the y don't exist, right? So we'll use the quadratic formula as usual. And our answers are just going to be x is equals to 1 or x is equals to 3 over 2. So when you take this to the other side of the equation, what we are supposed to have is x minus 1. So let's go to this one. So what are we going to do? Notice we've got a fraction. If we have a fraction, we also have to make this a fraction, right? So now that both of them are a fraction, notice that we can just cross multiply. So when you cross multiply, this is going to be 2x, and then this side is going to be 3. So our job is just to take this to the other side of the equation. So if we take it to the other side of the equation, we're going to have 2x minus 3. So this is what we're supposed to have, right? However, because there are y's, what you'll do is just simply add a y at the end, and you're done. You're factorized. So note that this one y is just the same as saying minus y, right? So it's just the same as saying minus y. So there we have it. So we're going to do the same thing in trig, right? So what we're going to do is that we're going to write this in a form of trig. So this is going to end up being sine x minus cos x. And then this we're going to have 2 sin x minus 3 cos x. So whenever you've got this stuff, you can choose to ignore the cos's, right? And then you just type this in a quadratic formula. When you get your answer and you reverse the process, make sure you remember to put cos back, right? So we have just pretended as though we are factorized. So then we have max, right? So now this is going to end up being sine x is equals to cos x. And then this is going to end up being 2 sine x is equals to 3 cos x. So our job is just to divide by cos again, because whenever you've got this situation, you have to have tan. So then this is going to become, when you divide both sides by cos, this is not going to be 0, this is literally going to be 1. And then this side, when you divide both sides by cos, you're going to have 2 tan x. So you have to show the division by cos because of marks. So then we have this stuff. Then when we divide both sides by 2, we've got this stuff. And we've got the same answers. I don't think I have to repeat the general solutions. So there we have it.
Alright, we have reached the end of this video. I have included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.